Welcome everyone. Today we're going to learn about performance optimization in Unity. As Unity developers, we all want our games to run smoothly and efficiently, providing the best possible experience for our users, isn't it? However, as our games becoming more complex and demanding, especially in virtual reality, it is absolutely crucial to optimize their performance and ensure they run smoothly at optimal speed. Performance optimization in Unity is a big and complex topic, and I will have to spend here many hours to cover everything. So for the purpose of this tutorial, I'm gonna make things simple, and I'm gonna only teach you the best basic strategies and techniques. So at the end of this video, you have enough skills to hopefully optimize your game. So before we jump to the main topic, which is performance optimization, let me show you the scene that I've just built here. You can see it's like a labyrinth with lots of different rooms, with different objects. Let's press play and see how that works. Okay, seems to be all right. It's running smoothly. I can interact with objects. I can hear the sound effects. I have no errors in the console. Well, that's great. It looks like the experience is ready to be built. So let's do that. Let's go File, Build Settings. Make sure you have your scene chosen and you have the WebGL platform chosen. Just hit Build, select the folder you want to build it. And as soon as we finish building, I'm going to put the code on a canister and then we're going to visit the experience in VR. See you in a bit. Okay guys, I just deployed the code on the canister. I've got my Quest 2 with me. It's time to visit the experience. All right. Ooh. It's not very nice. Oh, it's a little bit glitchy. Not very comfortable at all. Ooh. Not great. Ooh, I think I'm gonna get headache. I think it looks like the FPS value, it's very low. Yeah, it's not very nice at all. You probably can't see it on the video very well, but in VR, believe me, it's not great. Fortunately, in VR, there is a tool that we can use to indicate the frame per second rate. It's the watch. And you can see, if I hold the watch like that, it is showing me the frame per second value. And as you can see, at the moment it's 45, which is not too bad. 45 is actually the absolute minimum you should be aiming for. So now it's not too bad. This is bearable, quite smooth. Let's turn this way. Oh, now it's becoming very glitchy. Yeah, 20, you can see it's 25, 27. Oh, it's not very nice at all. Gets better here. Not too bad. Oh, and again, this is not great. Let me walk around the whole scene so we have a reference. As you can see, it's mostly 30, which is way too low. Feels not very nice. Yeah. So as you can see, most of the time it's 30 or low. That's not great. Not great at all. Okay. I think I'm gonna get a headache. So let's go back to Unity, and I'll show you how to sort this out. The first thing I would like you to do is to organize your hierarchy. So if your hierarchy looks like mine, then I would really recommend you to organize it well. Okay, so I've got all my files organized in hierarchy. At the very top I have the ICVR camera set. Then there's the ICVR multiplayer beacon. Then I have the labyrinth, the whole building. Then I have a folder with all the lights. Then there is a folder with objects. And here I have all the objects that are pickable with hand, and you can also throw them around the scene. Then the next folder is boxes. And each box, you cannot pick it with your hand and throw it around. However, you can use your body to go against the box and move the box on the floor. Then the next folder is furniture. And in this folder, I put objects that the layer is furniture. So it's a table and all the cupboards. Don't worry about this too much for now. Then in the next folder, I put all the sofas. And these objects are a part of the scene. You cannot move them. You cannot pick them up. However, your body will interact with the collider of any of those objects. And then in the last folder, I place some other objects. So here we have curtains. We have DJ folder with jukeboxes. So I put here all the stuff that is related to audio playing. So we have all the speakers, DJ, we have the disco ball. We also have our vortex, some posters, another vortex on the other side of the scene, another poster. Okay, so now we have our folders organized properly. We can finally start talking about performance. Okay, so here we have ICVR performance optimization loop. And this is a workflow that we are going to use to optimize the performance of our experience. And the first thing you need to do, you need to define your performance targets. Then you need to go to Unity and gather performance data. Once you've done that, you have to interpret this performance data and identify bottlenecks, which are things that are slow, making your game to run slow. Then you should perform some actions to get rid of those bottlenecks. And once you've done that, you should gather the performance data again and check them against your performance targets. If you reach your performance targets, your job is done and you can deploy your experience and share it with other people. However, if you didn't reach your performance targets, you should go through the loop again until you reach your performance targets. So you might ask me how I can define the performance targets. So I'll make it easy for you. I'll show you how I define mine. You can follow it. So here are my ICVR performance targets. My target device are standalone headsets like Quest 2 or Pico 4. My target FPS, frame per second, in average should be around 50 FPS and minimum 40. And it should never drop below 40 because VR experiences that run below 40 FPS, they are very likely to cause motion sickness for users. So here is my performance definition. My target device is Quest 2. My VR experience should run at 50 FPS most of the time. My VR experience should never drop below 40 FPS because I don't want my users to get motion sickness. Okay, so we have our performance targets defined. So now let's go back to Unity and gather some performance data. Let's press play. And now here in the corner, we have a stats window. And you can see here all sorts of numbers. To make things simple, let's focus only on those two numbers, which is the number of batches and the number of trees. And as you can see, when I move around the scene, those numbers are changing, and it depends on which direction I'm looking. Sometimes it's 100, sometimes it's 130, 140, 90. And let me walk around the scene and we will gather some data by recording this video. So you can see it really varies. Sometimes you can have as low as 25. Sometimes you have quite a lot of batches and trees, like for example in this position. 153 batches, 142,000 triangles. That's another hotspot with lots of triangles and batches. Let me go this way. Here is not too bad. Let's go down here. Oh, here we can see there's a significant amount of batches and trees in this spot. Oh, as soon as I move right, it's getting so much better when I look this direction. Yeah, it's very good here. Oh, it's not very good here. Okay, so here I gather all the performance data we've collected. So as you remember, we deploy the experience on the canister and we visit the experience in VR and we use the FPS watch to see what is the FPS value of the experience. And we walk around the experience and the average value was around 30 FPS. I think in some places were as low as 25 FPS, which is really low. And in some other places, it was 45 maximum. And then we went back to Unity. We opened the stats window. We walk around the experience to gather some data. And we find out that in some spots, there is as little batches as 25. However, in many other spots, there's lots of batches, sometimes even 140. We've also collected data regarding the trees count. So minimum we have like 6k, which is okay. And in many spots we had much more, reaching values even 170k trees. So let's check the performance data we just gathered against our performance targets. And we can see that we are not reaching our performance targets just yet. Because we're supposed to have in average 50 FPS, and we should never drop below 40 FPS, because that will cause motion sickness. So to reach those FPS value in VR, I would highly recommend you to optimize your experience and decrease the amount of batches and the amount of trees count. So you should end up having, in the whole experience, you could never have in any places, you should never have in any places more than 80 batches. And you shouldn't have in any places more than 80k trees. Okay, so we gather the performance data, and now it's time to interpret that data, identify bottlenecks, and perform an action plan. So let's go back to Unity. Okay, let's press play. Don't move. And let's see what are the initial numbers. So we have 97 batches and 54,000 triangles. Okay, we will start optimizing our performance with static batching. So you need to make sure that the static batching is enabled in your project settings. So go to project settings, go to player settings, and here under the graphics APIs, make sure that the static batching is enabled, and you have tick right here. Okay, now we need to make sure that all the objects in the scene that are the part of the scene and they not move, we need to give them a static flag. So let's start with labyrinth, because labyrinth is the whole building. The building is static, it's not moving. So we have to put a static flag on the labyrinth. So go to inspector, and here in the corner, just leave that tick. So now a labyrinth is now a static object. Then we have lights. Don't worry about lights. You don't need to do anything with them. Then we have folder with objects. And those objects are not static, because poker card and chair, you can grab it with your hand, you can move it around the scene, you can throw it away. So therefore it's not static. Boxes are also not static, because you can move them around with your body. So when you go against the box, you can move the box around the floor. So boxes are not static either. Then we have furniture, and furniture is definitely static. So you have to put the static flag on every table and every cupboard. So let's do that. Next folder is sofas. Sofas, they are also a part of the scene. They do not move, and your body collider will interact with the collider of an object. So yes, we should put the static flag on each single one. I can actually mark them all like that, and then just press that, and now they all static. Let's go to other objects. Curtains. I would say all curtains should be static. go to DJ folder. And I would say that each jukebox should be static. Then we have DJ stuff. Let's open that. So the platter is actually, it's not static, so let's leave it as it is. But when you open the player should be static. And do yes to children, because the head is also static. Okay, second player, the same. Yes to children. Then a speaker should be static. DJ table as well. Okay, next one is disco ball. The ball is moving, so let's keep it as it is. But the cylinder and the other cylinder is static. Then we have the DJ stuff again. So again, make sure the platter is not non-static, and player and head is static. Yes to children. And this one, yep. Yes to children. Speaker, second speaker, DJ table, jukeboxes, I've done it already, and there's one D-ball. Let's put the cylinder static, another cylinder static. We also have vortex. The vortex is not static, so let's not put the flag. The poster is static. Then we have a second vortex on the other side of the scene. Let's leave it as it is. And we have the last poster that's supposed to be static. Okay, so we put all the possible static flags in place. So let's press play. And we can see that we manage to drop few batches. Not many. We used to have 97. And now, after putting the static flags, we have 90. So there is a little bit of improvement. That's great. Okay, so the next thing we can do, we can investigate how far is our camera rendering. So let's go ICVR camera set. Let's go character root, and let's go main camera. And here we can see how far the camera is rendering the scene. So it's all the way up to this plane here. So that is a bit of a waste. Looks like the camera is rendering more than it should. So here in the camera settings you have clipping planes, and you have a near and far clipping plane. So this plane here is the far clipping plane. So I would recommend you to reduce it. Let's put 30. And now we can see that the clipping plane reduced a lot. Okay, let's press play and see how that works. Right, we can see that our batches dropped dramatically and the number of triangles dropped dramatically as well. Now we have 52 and 20,000. We used to have 90 and 50,000, so we're doing very well. Let's walk around. And we can see that we no longer have... Oh, maybe this spot is quite bad, because we still have more than 80 batches. Here is not too bad. Oh, here is on the edge, so it could be better here. Here is quite bad. Okay, so it looks like we're getting much better. Okay, so now we still have two other cameras that are responsible for rendering in VR, and we need to reduce the far clipping plane on those cameras as well. Because I can see this one is 1000 and the other one is 1000 as well. So let's change it both to 30. Okay, now it's all done. Now all the cameras are set to have far clipping plane at 30. Awesome. Okay, the next let's press play now. Let's go far. And let's see here. We're just looking at the wall. But it looks like we are still rendering things behind the wall. Because we have 43 batches and 21,000 triangles. If you swap back to scene, you can see that your camera is the far clipping plane is at 30, so it will be rendering things that are behind the wall. But there is a way to sort this out. It's called Occlusion Culling. First you need to make sure that your camera enables that in your camera the occlusion culling is enabled, so that's okay. Same for the VR cameras, left camera, right camera. Okay, let's go window, rendering, occlusion culling. And now we can see here we have a new tab called occlusion. So let's hit bake. And we can see that some of the objects now disappeared. Okay. Let's click on the main camera. And now we can see that our clipping plane goes up to here. But we are no longer rendering objects that are behind this wall. But as soon as I disable the occlusion culling, you can see those objects are back again. So let's enable. Let's press play. And now we can see that our batches and triangles really drop dramatically. And even here, like next to the wall, we only have 14 batches and 3000 triangles. Previously, I think we had here about 40 and 20,000. So it looks like we are no longer rendering things that are behind that wall. So let's swap to scene view. And we can see here that we are standing behind this wall, but our camera is no longer rendering those objects behind the wall. Let's disable occlusion culling, and now we can see them again. And now if I go back to game window, you can see that my amount of batches and amount of trees are back to previous values. So let's make sure this is enabled. Okay, so the next thing we will do, we will make sure that all textures in our whole scene, they have the right format and the right size. So let's start with the labyrinth. Let's go to inspector section. Let's find where is the material. Let's click on it. And now here we can see we have that material. Let's click on it again. And here in the inspector we can see that this material has only one component, one texture. Let's click on it. It's here. Let's click on it. And now we need to make sure, let's click this tab, WebGL settings. we need to tick override for WebGL and make sure we have the RGB compressed DXT1 format chosen. And let's hit apply. Okay, good. Now we're gonna do similar things for all the other textures in the scene. So let's go lights. You don't need to worry about lights. Let's go object. Click poker card, click on the material. And in the inspector, we can see that this material consists of two textures. The base map texture and the metallic texture. It's probably the same for the other ones. Yes. Okay, so let's choose all the base map textures. Override for WebGL. Make sure you have RGB compressed DXT chosen. And because the card is very small, we don't really need such a high resolution texture on it. So I would recommend you to reduce this to 512 and now hit apply. Okay, we can see that now the textures are set. We still have to do the metallic texture. You can also make it way smaller. However, for any other textures than base maps, I wouldn't recommend you to change this for DXT5. So in case of the metallic map, let's keep the format RGBA compressed DXT5. Apply. Okay, the next object on our list is the chair. Let's click on the material. And this material only has one texture, base map texture, which is this one. So let's override for WebGL. Table doesn't really need to have such a high resolution, so let's change it to 512. It's a base map, so compress DXT1. Apply. That's good. In this folder we have one more texture, so let's do it straight away. Override for WebGL. This is a sofa. I also say that you don't really need to have such a high resolution. Let's do 500. Change this to compress DXT1 because it's a base map. Apply. Okay. Let's go to next object on the list. Boxes. Let's click on the material. And here we have the folder with textures for the boxes. As we can see, let's click on the material. And here we can see the material consists of two textures. One is a base map texture, and the second one is an emission map. So the base map texture is this one. Let's override it for WebGL. Maybe we can drop to 1000, and let's keep the DXT1 format because it's a base map. All right. Now let's click on the emission map. Oh, the emission map has been already done for us. That's good. However, I would reduce the size. And in case of emission map, the RGB compressed DXT1 is a correct format. So let's hit apply. Okay, so we have all the boxes done. We have three types of boxes and they share those textures, so that's okay, so that's done. Next one on the list, we have furniture. And we have a table. There's a pocket table material, which is this one. Has actually two components. has a base map and a normal map. Let's click on the base map texture. It's this one. It's a table, so it doesn't really need to be super high resolution. Let's do 500 and keep this format because it's a base map. Apply. And on this material we also have a normal map. We need to override for WebGL. You can drop it even to 256, but for normal map, keep the RGBA compressed DXT5. It's important. Apply. Okay, next one on the list is cupboard. There's a material, and this material consists of three different textures. So there is a base map texture. Let's click on that. Override for WebGL. That doesn't need to be the resolution the highest. 500 is enough. DXT1. Okay. Then we have metallic map. Keep the DXT5 because it's a metallic map, but change it to 500, 200. Normal map, override for WebGL, and keep the DXT5. Apply. Okay. Then we have some sofas. So here we have, so this is, I think, the corner sofa. Yep. So this corner sofa has few materials actually. And those materials consist of few textures as well. So it doesn't seem to have a base map. It's just a color. But then it has all sorts of other textures. So let's click on the normal map. And then I think here we have all the other ones in the same folder. Okay, let's do the job. So this one, override for WebGL. Change it to 200, keep the DXT1, apply. Next one is normal map, override 20, keep the DXT5 because it's a normal map. Apply. Sofa. Override, oh my gosh, this is very big. Apply. Apply. Okay. I think we have the corner sofa we have done. The next one is this armchair. Let's click on the material. The armchair we have already done. Yeah, that's good. Then the sofa is sharing the same material, so it's done as well. Okay, that's it, that's good. And then other objects. Let's go curtains. What we've got here. Okay, so this is the material. It consists of the base map, which is this one, and specular map, that is this one. Okay, so let's swap this one. We can drop this to even 256, I would say. And then the specular map as well. But let's keep the DXT5 because it's a specular map. Okay, so the curtains are done. Now we go to jukebox. And we have two materials for the jukebox. The glass. Glass is a very fancy glass. Because the glass material consists of like 3 different textures. So we have base map. Let's override WebGL. That doesn't need to be that complicated. I think in this case you want to keep it DXT5 because it's a transparent material. Then the metallic. Apply normal. 1000 here. And this is the base map, so I can change it for this one. Apply. Let's finish that. Apply. Okay, I think the jukebox is done. Now we have to go record player. Two textures. They're already in this folder. Okay, this one is already done for us. This one is also already done. This one is already done. Okay, so we have the DJ stuff sorted. Next one is the D-ball. That consists of few textures as well. So we have this albedo. Override it. Maybe there's 1000. And because it's albedo, I think we can put it DXT1. Normal map. That's the specular. Let's keep it DXT5. Apply. Okay, now we have vortex, but we have to go to here, fractal rainbow material. There's only one. Override for the WebGL. Let's make it a little bit smaller. The resolution. Apply. Poster. Okay, poster is done. Okay, I think we have done everything. So now we changed all the texture to the right format, and we also reduced the size to save some performance. There is still a few things we can do. Let's go to lighting tab. And here we can see that at the moment we have two non-directional light maps. And when you go to the baked light maps tab, you see that you have two baked light maps. And that is not ideal, because you ideally want to have just one light map. That's much better for performance. So if you go back to scene, you can actually increase the light map size. Let's do that. And now hit generate lighting. It's gonna take a while. Baking lighting is usually a bit time consuming. So it's still working on it. Nearly there. You can see that lighting is slightly changing in places and places. It's nearly there. 20 seconds, 10 seconds. All right, finally. So now we can see that here in the baked light maps, now we just have one big light map. But as we can see here, there is still like a little bit of a space on this light map. So it's a little bit of a waste. So if we could improve things, why not? So let's go back to the scene tab, and here is a light map resolution. And I will recommend you to increase this to 9. And now you should hit generate lighting again. Now we have to wait again for the light to bake. Forty more seconds. Thirty seconds. Ten seconds, nearly there. Okay, all done. And now we can see our light map is nearly full. Maybe we could go 10, but let's leave it like it is. Okay, so now let's press play. Let's watch the numbers. And we can see that the numbers are reduced dramatically. Now we have like 10,000 triangles, 30 batches maximum, 27, 28. Yeah, it's really good. Looks like we managed to improve things a lot. Let me walk around to gather the data a bit. Yeah, it looks like it's 40 batches, 30. Let's go here. Yeah, this is maybe the worst place. The most demanding graphics is, but still we are within the limit, so it should be alright. Oh, previously this corridor had like 170 and 140,000. Now it has 15. We did really well. Yeah, it's really good. Yeah, we should get a really nice performance. Okay. Okay, I don't seems to have any errors in my console. So it's time to build the experience again. Go to VR and see how well we did. Because we're gonna check how many FPS we have on the watch when we're gonna walk around the scene. Okay, let's build. Okay, so I just deployed the code on a canister. I have my VR headset with me, so let's check the performance. We can see straight away it's 50, and it feels really nice, really smooth. Let's see, we have mostly 50 now. Let's walk around the whole scene and let's see how well it performs. Really good. average we have like 50 or even more. Yeah, it's running really smoothly, it's very nice. 54, 55, 60. Now we have even 60. Let's go here to the red room. And yeah, it's all good. Let's see here. Maybe you remember that previously in this place we had like 25. Now it's like 55. So we did really, really well. Yeah, it's mostly 55. Okay, I nearly finished walking around the whole scene. Let's go back to the beginning. All right, excellent. All right, really good. Haha, no headache this time. Okay, so this is how well we did. So that was before the optimization. We had a very poor performance, very low FPS, and also we had so many batches and so many triangles in the scene on the stats window. Then if you see, like after optimization, we managed to increase the amount of FPS significantly. Like the average was 52, the experience never dropped below 40, and sometimes it was even 60. Also, the stats window in Unity was showing very little amount of batches and triangles. And then if you compare this against the performance targets, we hit the performance targets very well, because we never drop before 40. Our average was even more than 50, and we never had more than 80 batches and more than 80k trees. You're like, you wanna be famous, I'm trying to be out,